Good morning, everyone, and welcome to today's Jeeps Media Group webinar with Siemens. Today, we'll learn how grain companies can align with NFPA 70B to improve safety and reliability. In this webinar, you'll receive an overview of the NFPA 70B standard for electrical equipment maintenance and explore the practical steps grain facilities can take to meet this standard, including the servicing and equipment condition assessments. We'll learn how Siemens helps grain companies comply with the standard by remotely monitoring company assets without modification and reducing downtime with predictive maintenance solutions. We'll also learn about Siemens digital power solutions and how they address data challenges in the grain industry. These solutions make it easier to integrate devices into an infrastructure for maintenance, making system management in a factory more efficient, secure, and cost-effective. Our presenters today are Jason E. Asinero and Chris Allison. Jason serves as the Solution Portfolio Manager at Siemens AG, where he specializes in digital transformation of power distribution systems. In his current role, he focuses on developing innovative solutions for energy management and power distribution challenges, helping organizations optimize their electrical infrastructure and enhance operational efficiency. Prior to joining Siemens, he accumulated 22 years of extensive operational leadership experience in the meat manufacturing industry, serving in key roles including plant manager and vice president of operational excellence. Jason's contributions to operational excellence have been recognized with the Smithfield Foods ROI Innovation Award, highlighting his ability to drive meaningful improvements in manufacturing operations. Chris Allison is the president of Explore Systems and Industry, LLC, a firm dedicated to delivering advanced Industry 4.0 and 5.0 solutions tailored for the supply chain and manufacturing sectors. While focusing on enhancing the reliability of electrical equipment and cyber physical systems, Chris applies cutting-edge technologies to modernize industrial operations. He brings over 34 years of experience in electrical engineering, leading major initiatives in smart manufacturing, digital transformation, and automation. Today, Chris consults internationally on supply chain modernization, electrical infrastructure reliability, and smart factory implementation. He also lectures in engineering design and robotics at Texas Tech University, where he shares his industry expertise with the next generation of engineers. Before we begin, I'd like to point out that questions for the presenters can be entered at any time during the webinar by typing in the question box in the upper right of your screen. We will address your questions after the presentation. And now I'm ready to turn it over to Chris and Jason.
Thank you for the kind introductions. My name's Chris Allison, and like he said, I've got over 30 years experience in industry, the food industry in particular. I worked at Frito-Lay and for PepsiCo, Frito-Lay, and Quaker. And during that time, I was going to explain to you my journey with SmartGear. And how I, as a user of the SmartGear technology, how I used it and what were the things that triggered my needs for it. And then we'll roll into how that company is now using it for 70B compliance, and how the SmartGear is really a co-worker type of technology to help manage that program. So years ago, and it was over 15 years ago, we had a plant in Texas, and they were seeing a large amount of problems in power quality. So this kind of manifested itself in a high harmonic content of the power there. Some of the problems actually affected some of the neighboring industries. Some of the grade crossings for the railroad would start signaling for no reason other than it was caused by these harmonics. And there was other power quality events, mostly weather related, with sags and outages that were weather related, that were a huge burden to the facility. So at the same time, we had a new process line going in at that facility, and we had specified and purchased Siemens Smart Gear for that. And within that, there was, as we were discussing some of these power issues that we had, some of the Siemens engineers brought forward that they could use the Smart Gear to help diagnose those issues. And sure enough, they found that it was a single source for the harmonic content. It was some fixed capacitors up on the medium voltage line that was placed by the facility out there to try to reduce their power factor charges. So anyway, we were able to remove that and reduce that problem. But more importantly, I think the number of sags and so on they got from, whether it's local lightning strikes or what have you, the utility company worked with us with the data that we used to help harden the loads at the facility. So, you know, it's a huge 20 megawatt facility, or huge for PepsiCo anyway. And it was not practical to harden the whole facility, right? So we just wanted to find out which loads were being affected by those sags that was causing the downtime at the facility. And we were able to pinpoint those by using the technology and the data within Smart Gear to find that. So that's really where the first purchase of the Smart Gear happened. And it was a good success story. But then through that, we started working with the Siemens engineers again with Smart Gear to try to figure out, was there other things that we could find out from that. So typically, the facility was probably 50 years old at the time, somewhere around there, 40 to 50 years old. So I had just the normal breakers of that era installed, and so every time a breaker would trip, it basically one of the technicians would reset the breaker, and maybe there was some investigation with that, sometimes no, but most of the times it was just a mystery of why it might have tripped. But with the Smart Gear, we were able to actually start recording that and finding out what those problems were. So the facility had some operations like extruders and so on. So if there was any breaker trip on that, it could take up to 8 to 10 hours to clean out that extruder because the material would harden inside of it. So it was really quite a problem at some of these breaker trips and so on. So we found that there were some of the things that we needed to do to modernize some of the infrastructure there, perhaps work with the breaker trip settings, things like that. So the other thing we came up with is that, every time we needed to replace breakers or so on, we went in with smart breakers when we did those replacements, because of the amount of data we would get from that, and the up cost of that based on just replacing it in kind was not that much greater if we were going to have to replace it anyway. So that, what I would say, was phase 2. And then phase 3 was as we saw that we were able to start hardening some loads. Now we wanted to look at, could we do it for the whole facility? So the facility had about 12 substations. A lot of those weren't Siemens. All of them except the new one were not Siemens. So how did we connect all that into the Smart Gear, where we were able to do that? We were able to do that through, just installing smart meters on existing gear, and for ones that did have smart technology, whether they were Siemens or not, we were able to connect them as well to the Smart Gear IE platform to start taking that data and start using that data to optimize There you go. Sorry. And to optimize the system. Phase 4 was they nearly doubled the size of the facility, so there was a greenfield expansion. And in that case, we built it all from new from the beginning, utilizing smart gear from the beginning. And then phase 5, which is what we're here to talk to you about today, was we came full circle. We had all the smart gear installed on every substation. Is that now 7dB was going to be required by insurance carriers or managers, risk managers at the company, and also some jurisdictions that facilities were in were also going to be required to start using 7dB. And so since we already had a lot of that infrastructure in place, some of it we had to add to do it. We started doing the 7dB by utilizing smart gear to help us manage that. So what changed? Well, in 2023, the National Fire Protection Association changed their requirements for electrical maintenance programs. It's their standard 7dB. It was always a recommended practice, but in 2023, it transitioned into being a standard. And so what that means is it became something that we recommended to do to something that now some jurisdictions, insurance managers, OSHA, things like that would be looking at 7dB compliance, whether it's through investigations or perhaps annual audits like insurance carriers might do. And so we'll get into a little bit about what that means. But in the case with the company I worked for then, where we had been doing maintenance really based on, really run till it breaks down, breakdown maintenance, a lot of people call it. But a lot of that had to do with, electrical infrastructure is really abstract to people outside the electrical field. A lot of it is, I got a breaker panel in my garage. I don't do maintenance on it. What do you mean we've got to do maintenance? That sort of thing. But equipment failures are very costly. And there's a big safety aspect of maintaining your electrical equipment, as you well know. And so although a lot of the 7dB practices, recommended practices were being followed, I would say it wasn't in a cohesive, total, systematic viewpoint where they may have different people managing different parts. One person may be responsible for infrared scanning, where the other one's doing arc flash studies, for example, managing that program. And so they were kind of being managed in silos. But the change in regulations said we had to change that. And the number one thing that it says is that we have to have an electrical maintenance program, an EMP. And that's the number one thing. And from that, it's really looking at how do we systemize all that maintenance activity to give us a much more robust and safe and reliable electrical infrastructure system. And so now it goes from looking at, okay, we've had an event, let's go correct it, let's go fix it, to how do we proactively take care of those things. And so that all goes to risk management. So the engineers that I have typically worked with, I've always said job one is managing risk, whether that's managing costs risk or schedule risk on projects or the performance of the equipment, that risk. And that's really what 7dB is about. Number one, it's looking at the, let's mitigate or try to eliminate all we can on the safety risk for not only people, but for the equipment in your facilities. It's looking at, how do we prove compliance? So if the jurisdiction that your facility is in requires this as well. How do you prove compliance? And how do we ensure that as personnel changes work, we all seen the workforce challenges over the last few years, getting people that can do this. How do we make sure that it's being done properly and planned properly, and how do we report it out? What are those risks that we're trying to mitigate? And so Smart, Jason will get into how Siemens is helping do that. So they augment the workforce with their technology, the Smart Gear technology. And so Jason will cover that in a moment. But for those of you that aren't familiar, have had a 70B training, I just kind of wanted to cover what's really required by 70B. What does it mean to say that we're in compliance with 70B? And really, like I said before, the number one thing is that you need to develop and design an electrical maintenance program. This would talk about all the activities and how studies, how all the information and data that you collect, how do we manage that? And then what do we do with that? And what activities do we plan from that? So that's what the electrical maintenance program does. 70B is very prescriptive that you have one. It's not completely prescriptive, here's a checklist, although it does have checklists for some of the maintenance activities in case you can't get them from your equipment supplier or something like that. The other thing is that key personnel and that have to work with the electrical equipment or the 70B program, there's key people, and those are both internal and external. So with the facilities I helped work with, most of them, for example, didn't work with medium voltage that often. So we had a policy that if it was over 600 volts or 600 amps, since their experience was very limited, they weren't to do the maintenance on that. So we'd hire outside resources. Well, those outside resources also have to go by this 70B plan. And so that's one of the other key components. The other thing is if you read through the standard or you take a training program in it, you'll find that there's a number of surveys and a lot of analysis that has to happen with those surveys. Some of them you're probably already doing, so there is some overlap. It requires an arc flash study, for example. One thing that was kind of new to the organization I worked with is that now load flow studies were required every 5 years, things like this. So it started looking like all these things became quite burdensome. How we were going to manage this across 45 different facilities. Some of them were grain handling facilities, some were food manufacturing facilities in North America. How were we going to manage through all of that? And so the Smart Gear, which Jason will go into in a moment, it helps you manage those activities and helps store all the information that you get from that to reduce the burden. Also, there was fundamental tests. So these are probably already things that most of you are doing. So you may hire these out to either the supplier or maybe a third party to go test the breakers, for example, that they actually operate as they're supposed to, that the settings in them actually work as intended. So there's a lot of those that are required. And then any incidents has to be investigated. So this isn't just the typical safety incidents that most of you do as part of your investigations, but it could be a breaker trips. Why did it trip? What were the conditions that set that? What were the root cause? So that's also part of 70B. And the last part is determining the condition of maintenance. And so what level of maintenance do we need to do based on age, based on the condition of the equipment, based on the number of, say, faults that we've detected, maybe other things that we detect like temperatures of bus, condition of oil and the transformers, these sort of type of things. So that's the other part of 7DB, is that we have to determine the condition of maintenance to determine what activities and when those activities need to happen. And so, like I said, all of this is about mitigating risk. So we're looking at doing maintenance proactively versus waiting for something to occur. We also look at increasing reliability. So the reliability of the electrical infrastructure in your facilities is very important to the operation of your facility, obviously. And so the more reliable we can make that, the safer we make it, but also we can optimize the efficiency of the facilities by keeping the electric utility up. We also look at cost management. So, 70B, how big of a burden is this going to be? Well, I think with smart gear, we can reduce that burden of the cost to actually implement it. But it also helps with the efficiency of your facility by keeping breakdowns and interruptions to your electrical infrastructure to a minimum. And then we'll also look at how do we optimize the resources. Like I said, most industries are seeing workforce development issues. It doesn't matter whether you're in semiconductors, whether you're in food, whether you're in grain handling. All of these industries are seeing difficulty in getting the right resources. So how we use those resources, so we don't want to just be doing maintenance activities that are unneeded or unnecessary to get in the way of actually operating your facility and using your resources to the best. So try to wrap up on how I had used this as one of Siemens customers. Is I really looked at for the full life cycle of the electrical distribution system. How do I manage that? So it always starts out with design and standards, and this also we looked at using what kind of maintenance activities. We try to design things to be easily maintained, to be reliable. But we also looked at the maintenance cycles within that life cycle of the equipment. How can we better maintain the equipment? And then how do we harden it? Like I was talking about, how do we harden it against maybe events that can't be controlled, like weather events, things like that cause sags in the plant. So through that full cycle, if you look at this life cycle, if you look at the Venn diagram I've kind of put together here, is that 70B really spans the full life cycle of the equipment. If you start by designing with 70B in mind, if you're building a new facility, you should consider putting in smart technology that has the ability to help you manage the maintenance and the operation of your electrical distribution system. But you can also really use it to help you manage your maintenance activities. And like I explained in the very beginning, you can also use the smart gear to help you harden your equipment against events. And so that's my experience with the smart gear and how I've used it in the past among a fleet of 40 facilities. It's still a continuing journey, I would say. It's still ongoing. It's not something that was a one-time, let's install it all event, but it's continuing today, and that good outcomes have been seen by every facility that's been touched by this. So I'm going to turn it over to Jason, who has been instrumental in a lot of the design and installation of a smart gear IE, and I'm going to let him explain a little bit about how Siemens is helping with the 70B compliance.
Thank you, Chris. Good morning. So, just like Chris was talking about, from a Siemens perspective, we have a product called Smart Gear. And in that product, Smart Gear, we have an application that is a digital solution to help implement, manage, and document your electrical maintenance program. It helps you plan, schedule, and record all of your maintenance actions and supports continuous monitoring and predictive maintenance. This is about cost control too, so reducing unnecessary interventions or automating your compliance tracking and enabling data-driven decisions for improvement. This tool turns NFPA 70B from a paperwork burden, like Chris was talking about, into a strategic asset. So to go just a little bit deeper dive into the EMP, on this slide, I'm sharing you is conditions of maintenance. So as Chris was talking before, the run to failure type of maintenance program or time-based maintenance can be very expensive and it can be ineffective. And today what I'm sharing with you is what the condition of maintenance criteria looks like through the NFPA 70B standard. And there's 3 conditions that I'll walk you through. So the first one on the very top is condition 1 criteria, which is basically your equipment is in new condition or like new, and there's no active issues on it. The second one is condition 2, which is degraded components or predictive alerts that exist. And the third one is condition 3 criteria, which is equipment's missing its maintenance cycles or it has unresolved alerts. But how do you get from condition 3 to condition 1? And as you can see on this chart on the right, from I've got switchgear, switchboards, substations, and so on. There's dozens of different criteria and category on different electrical pieces, but these are the big ones. So imagine going from a run to failure type of maintenance or to doing maintenance over 12 or 36 months. There's a huge financial cost of doing that. So how do you get from condition 3 to condition 1? And with an EMP, continuous monitoring and proactive maintenance is essential for you to be able to do that. And Siemens gives you the ability to do that with software solutions to make the triage process visible and in real time, and then letting you prioritize your high-risk assets and extending the life for your low-risk ones. So what problems are we trying to solve? What are the key challenges that Siemens can help you address? First, it enables proactive maintenance by identifying issues before they become failures. Like Chris said, that when you have a failure, there's a lot of implications. It's usually a low frequency, high severity type of event for power distribution equipment. And these downtime events can lead to hours to days, sometimes to weeks to downtime, depending on what kind of failure you have in the power distribution system. Secondly, is supporting reliability and detecting early signs of failure so you can keep your operation running at its best. Third is helping with cost management by targeting maintenance and minimizing downtime. Maintenance can be very expensive, and it's best if you can do that with database decision. And then lastly is optimizing resource use, ensuring your people and equipment are used where they matter most. And in short, it aligns safety, performance, and efficiency. So making NFPA 70B compliance simple and scalable is important. So to meet the NFPA 70B standard, it's essential to have a clear, organized system for tracking inspections and maintenance. That's where our tools come in. Maintenance services that we have can help you document and digitalize all your maintenance records using Smart Gear and other Siemens services, which also includes a centralized storage for your records, your manuals, your drawings, your inspection logs, your one lines, all accessible from a single app on your laptop, giving you quick access to those documents. Secondly, our Edge compliance app gives you a real-time dashboard showing the status of your electrical equipment. It alerts you when inspections are due and also stores all the reports in one place so you have easy access in auditing. And then finally, if you have more than one location, scalability is very important. So looking at enterprise compliance, to help companies with multiple sites, we offer centralized tools to track compliance across all locations with a single pane of glass, giving you the same ability to look at equipment status, continuous improvement indicators, and various other information to help you manage your EMPs from a large global scale. So how do we do this? I have this very simple topology to kind of show how this works. But basically in the bottom side, we have modern equipment devices that are becoming smarter thanks to Internet of Things technology. These smart devices talk to each other using standard industrial communication protocols. And for equipment that supports IoT or Internet of Things inspections and performance are automatically tracked and managed using industrial edge technologies. This system helps keep everything running smoothly and efficiently. But even if some equipment isn't IoT or internet ready, it's no problem. So like Chris was talking about, modernizing your power distribution system takes time, it takes effort, but not a problem. You can still be able to load those inspections, you can still plan them, and you can still record them and review those manually as facilities are working on modernizing their power distribution equipment through the capital management process. And then all inspection reports on equipment statuses are managed through our industrial edge technology, which is above the switchgear or the apparatus there. And it allows you to manage your applications using Clearview and be able to see what's happening across all of your equipment at location. And then finally, we send the data securely up into a cloud-based server, allowing users to monitor and perform health and performance of their equipment, whether it's in one building or spread across the globe, all from a single dashboard. So to wrap up, NFPA 70B compliance is not just a checkbox, it's an opportunity to modernize how we maintain our infrastructure. With Siemens, we can help you predict failures, prevent disruptions, perform smarter, safer maintenance, and help you move from reactive to proactive, and help you modernize your systems to prepare for electrical maintenance programs, giving you the ability to predict, prevent, and perform. With that, I will hand it back over to Tucker for Q&A.
Thank you, Christian.